Okay, so let's start. See, so we are not going to discuss day 2 shift 1 paper here, and the question paper as the feedback I got, and now I have seen the questions also before coming live. I just went through the question quickly. So I found that the question paper was not exactly tough, but it might be a bit lengthy for actually I didn't get all the 25 questions. Okay, so whatever questions I got, I am going to quickly discuss them here for the reference to the students who are going to take the examination next in the upcoming shifts, maybe starting from tomorrow. Okay, so let's start. I think I am audible, bacho. Let me just quickly check it. Yeah, I think so. Yeah. Okay, so now see that's a really a simple question in that case. So that's wait for a minute, bacho. Okay, just a minute. Okay, sorry. Yeah, so if we go with that question, you will find that definitely that's a really simple question of trigonometry, isn't that, bacho? So we have to evaluate this value, which is sine 70 degree of cot 10 degree into cot 70 degree. See, even a 10th class student, what will he or she do? They will just convert it to cos and sine. So that's what I will also do here. So cos 70 into cos 10, and then take LCM. So it's minus sine 10 minus sine 70 degree upon sine 10 degree into sine 70 degree. So that these two terms get cancelled, and see, this is the direct formula, cos A cos B minus sin A sin B. So it's cos of A plus B. So it's cos of 70 plus 10, which is cos 80 degree upon sin 10 degree. And now we know that 80 degree and 10 degree, they are complementary functions. Okay, sorry, complementary angles. So they add up to give 90 degree. And for complementary pair of angle, sine of one is equal to cos of another. So this is nothing but sine 10 degree upon sine 10 degree. So answer should be 1 here. So if that's the question, see, these are all memory based question. Of course, you will get the original questions after all the shift end up. Okay, and here itself will be uploading it. But meanwhile, okay, we are solving the memory based question, which are definitely quite close to the original one. Few must be almost every, not every, but almost several of them will be same as the original question, but data may vary here. So number of ways in which letters of the word daughter can be arranged so that vowels do not come together. So okay, so I think you people are quite familiar with these type of questions. So no two vowel occurring together. We discussed several many such question in our class, isn't that? So it's D, G, H, T, R. So it's 4, 4, 8, 8 alphabets are there. So when no two vowel occur together, when a particular type of object has not to occur together, no two of them have to occur together, what do? We arrange the rest of the objects. So we will be arranging 5 consonants here. How many ways? 1, 2, 3, 4, 5. How many ways? 5 factorial ways, as all are distinct. How many gaps we get? We get 4 gaps here between them and 2 at the corner. Total number of gaps are 6. In these 6, you have to select 3 gaps and put 3 vowels. Of course, you select any 3 gaps out of these 6 gaps. You won't and put vowel in them. You won't have 2 vowel together. You can't have 2 vowel together because between any 2 gaps there is a consonant. So in how many ways you can select 3 gaps? In 63 ways, and then arranging 3% in 3 slots, or putting 3 vowels in 3 slots is 3 factorial ways. So that's the answer for the second one. So moving to the third one. So the third question is the range of values of A for which this equation has 3 distinct solutions in the interval alpha to beta, and then we have to find the value of alpha minus 2 beta, rather beta minus 2 alpha. So the range of values of A for which this equation has 3 distinct solutions. The degree of this equation is a polynomial equation. It's a 3rd degree polynomial equation. And if I go for the curve of the cubic polynomial involved here, this is it. So since the leading coefficient, the coefficient of cubic term is positive, so how will the curve start? The curve will start from negative infinity and it has to go to plus infinity. If it has need to have 3 roots, so of course it need to have 2 turning points, 2 stationary points, and the stationary points are the points where the derivative is 0. So go for its derivative f dash x, which is 15 x square minus 15 equal to 0, and you got 2 values. But having two turning points, is it sufficient to say that this polynomial equation will have three real distinct roots? Acha. Now you may say that they are talking about three distinct solutions. Where did they say that the roots are real? But then the solutions lie in this interval alpha to beta. Solutions lie in this interval alpha to beta. So of course they have to be real. Okay. So we have three real distinct solutions. For that I said the necessary condition is it need to have two turning points, and the turning points are +1, -1 and +1. Okay. But then, as I said, is it sufficient that we have two turning points and then we will get three real distinct solution? Answer is no. If that will be the case, we have only one solution, or if that is the case, you again have only one solution. So what we need is two sign changes. When will that happen? So the simple thing is value of function at -1 should be positive and value of function at +1 should be negative. As simple as that. Okay, now value of function at -1. So if I am writing it here only, where shall I write? F of -1. What is it? It's -5 plus 15 minus a should be greater than 0. So a is less than 10, and value of function at 1 is 5 minus 15 minus a should be negative. So a is greater than -10. So the range is -10 to 10. So a should lie in the interval -10 to 10. So alpha and beta both are -10. So the answer should be 10 here. -10 plus 20 should be the answer here. Okay, so that was a better question in this paper. And then this, okay, this seems to be a good one, no? Isn't that, bachon? So the integral is e raised to the power ln x whole square plus 1, rather 1 upon raised to the power -1, bachon. Okay, upon e raised to the power 1 upon 1 plus ln x whole square plus e raised to the power 1 upon 6 minus ln x whole square plus 1. That's it. When x goes from e square to e raised to power 4 dx by x. So see, the presence of dx by x separately in itself is the biggest hint here, and the hint is that replace ln x by t here, bachcho. It's a very, I mean, a different type of question, but directly based on Bahubali property, the most important property for us in definite integration. But to see that, we have to convert it to the simplest form. And see, again I will say the presence of 1 by x along with dx is the biggest hint to replace ln x by t. So replace it by t. So when you differentiate, you get dx by x is nothing but dt. And when you go for the limit change, when x is e square, so when x is e square, how much is t? T is 2. When x is e raised to power 4, how much is t? T is 4 here, bachcho. Okay, so therefore now our integral is, so I is, it goes from 2 to 4, e raised to the power 1 upon 1 plus t square over e raised to power 1 upon 1 plus t square plus e raised to power 1 upon 1 plus 6 minus t whole square, and that's your dt. Now apply Bahubali property. So what does it say? It says that if I replace the variable of integral here t by the sum of the limits minus t, so a plus b minus t, which is 2 plus 4 minus t. So if I replace the variable here but t here by 6 minus t, 2 plus 4 is 6 minus t, so it will be 6 minus t whole square. And then here, see what will happen, this term will be this term here, so it's 6 minus t whole square plus e raised to the power 1. When you replace here t by 6 minus t, it will be the first term here, this one comes here, but overall denominator remains same. And my students must be knowing it that I always say denominator, after applying Bahubali property, denominator remains same. That means we are on the right track. Okay, and then what do we do? Almost every time we apply Bahubali property, we add the given integral and the one obtained by applying the property. So since denominator is same, when you add them, so denominator remains same. So 1 upon 1 plus t square plus e raised to power 1 upon 1 plus 6 minus t whole square. And then here again, what do we get? So we get whatever we have in denominator itself, bachcho. That's it. So that's gone. So it's nothing but 2 to 4 dt, which is t, 2 to 4, which is 2. So I is 1 here because 2i is 2, so I is 1 here. So that was a beautifully designed question, a simple question based on direct Bahubali property, but to apply that property, look at that property, you have to make a simple substitution here, and whose hint is also given directly here as written as dx by x. Okay, so that's the question. Now moving to the next one, if for an AP the first term is 3, so A is 3, the sum of first 4 terms, so 4 by 2, 2A plus n minus 1, 3D, isn't that bachon, is equal to 1, 5, the sum of the next 4 terms. So sum of next 4 terms, see in that case the first term for the AP of next 4 term will be 5th term. Okay, so 2 times A plus 4D, isn't that bachon, plus 3 times D, that's it. So A is 3 here, so let's put the value, so that's gone. So this is 6 plus 3D, isn't that, yeah, so it's 1 by 5 times 2A, which is 6 plus 8 plus 11D, fine. So nothing more to do here, so it's 30 plus 15D, so you will get D from here, isn't that, so this is it, so that's 24 is equal to 4D, I think, yeah, that will be the case, so minus 4D, so D is nothing but minus 6, that's it. You have your D, then the sum of first 20 terms is, okay, so sum of first 20 terms is A is already given, D you have, so S20 formula, which is 20 by 2, 2A, 6 plus 20, 19 into D minus 6. You have calculated and you have the answer. It's a really a simple question, simpler than yesterday's question on GP, where again we were given A1 into A5 was something and then A2 plus A6 was something. So I mean, what the question we got, memory based question, was a bit wrong of course, but whatever the data would have been, 2 equation, 2 unknown. See, solving 2 equation and 2 unknown when the equations are linear is really simpler than solving 2 equation into unknown when they are non-linear, as in case of GP. But here it was not even the question of 2 equation, 2 unknown. A was directly given, you have to just find D using the given relation. So it was a simple question here. Moving to the next question, if set A has elements as 1, 2, 3, 4 and consider a relation on A. What does that mean? A goes relation is from A to A given by R. R is 1, 2, 3, 3, 2, 3. Okay. Now the minimum number of elements that must be added to R to make it an equivalence relation. See, for equivalence relation, of course, it need to see, I'm writing it there. It need to be a reflexive relation for sure, and to have a relation as a reflexive relation we need to have all possible self images. So 1, 1, 2, 2, 3, 3 is already there, so 4, 4. So now we made it at least a reflexive relation 1, 1, 2, 2, 3, 3, 4, 4. Okay, now go for transitive. So you have 1, 2, you need 2, 1. You have 2, 3, you need 3, 2. Now let's go for sorry, that was for symmetric. Now let's go for transitive. Okay, so what do we need for transitive? So what shall I use? Okay, this one. So 1, 2 is there, 2, 1 is there, 1 was there. Okay, and 2, 3 is there, 3, 2 is there, 2, 3 is there, 3, 1 is not there. Is it required? It's just a minute, not required. Okay, wait, 1, 2 is there, we have 2, 3, 1, 3 is required. Okay, see, we have A comma B, B comma C. So for it to be a transitive relation we need A comma C, which is 1, 3, which is not there. So I will add 1 comma 3. So to make it symmetry again we need to add 3 comma 1. Now let's again go for transitive case. Okay, so now we have 1, 3, starting from 3 is 3, 2, we have 1, 2 and we have 2, 1. That's done. Okay, 1, 3 so started, then we have for 2, 1, 2, so 2, 3 done, 1, 2, 2, 1, 1, 1 done, 2, 2 done, 1, 2 done. Okay, so we have to look for it. So now I think it's settled, we don't need anything else. So how many elements we need to add? 1, 2, 3, 4, 5, 6, 7. So you need to check it once carefully, but we have to like make create that set such that the entire relation, entire collection gives us a collection of our like what equivalence relation. Okay, so you have to do it. Okay, so you have to count the cases, you have to do it. Okay, yeah, Chakravarti, you are welcome, beta. Okay, so let's move to the next one. So that's a simple question. See, in the last day, yesterday also shift 1, they asked a similar question. They asked a similar question based on equivalence relations. Okay, so I think you'll be well prepared now. We have already done 2 such questions. Now see, that's a question of multinomial. So whenever any student came to me and asked me, I said only one thing is important in multinomial. It's general term, and we'll be using that thing only. See, the general term. So those who don't remember it, now you should not forget it. Its general term is given by, okay, so its general term is a raised power x1 into b raised power x2 into c raised power x3 upon x1 factorial into x2 factorial into x3 factorial into n factorial, where that's really an important relation. We can't afford to miss it, because that will give us a restriction here. Okay, now let's do it for the given question. So a is 1, so general term is 1 raised to the power, now I'm writing alpha. Okay, and then 2b raised to the power beta, and then c is 3 raised power half raised power gamma upon alpha factorial, beta factorial, gamma factorial into 6 factorial. Nothing else matter than this thing. That's the key. And now what do we need? We need the number of rational terms in its expansion. So how many rational terms we have in its expansion? Okay, so how do we do it? See, 1 raised power alpha doesn't make any difference. Whatever alpha be, according to this situation, alpha, beta, gamma are all whole numbers. Okay, they are all whole numbers, don't forget that. Okay, now see, beta. So beta by 3 should be an integer, gamma by 2 should be an integer. So beta should be a multiple of 3 and gamma should be an even number, multiple of 2. Now let's start. So if beta is 0, beta is 0. So what are the possibility for gamma? Gamma, 0 is an even number, gamma has to be an even number, gamma can be 2, gamma can be 4, gamma can be 6. Okay, so now what can be alpha? Alpha plus beta plus gamma is 6. Don't forget that. So 6, 4, 2, 0. So how many combinations we got? We got 4 such combinations. For beta 0, we got 4 possible set of alpha, beta and gamma. So 4 such things. And now what can be beta? Beta can be 3. So in that case, gamma can be 0, gamma can be 2, gamma can't be 4, because 3 plus 4 is 7, whereas we need the condition where alpha plus beta plus gamma is 6. So that's it. So alpha in that case is 3, in this case is 1, and that's it. So we have 2 possible cases. Similarly, when beta is 6, so gamma has to be 0, alpha has to be 0. So that's one case. So how many total terms? So 4 plus 2 plus 1 is 7. So there are 7 such terms in its expansion which are rational numbers, bachcho. So that's it. So that's again a useful tool, bachcho. No, don't forget it. In the expansion of this multinomial, that's the general term with this condition. Okay, only this much is important in this topic of binomial. We treat it under binomial. Okay, though, see, to be frank, to be true here, to myself, I will say I was not expecting a question on this thing or multinomial. Okay, but then they have it. Though we discuss it in our regular classes, but near the end I always said, okay, you may skip it. But if someone insisted, then I definitely told them the general term, and that might be useful for them in that case. Okay, so now let's move to the next one, bacho. Next is see, that's a really important and that's 11 here. It's not pi, it's 11 here. Okay. See, look at it. Rather, it is it's 13 here. I am correcting it, bacho. Okay, because when I was just looking at it quickly, just looking at it form, I said, okay, I really personally take it as a very important form here. Okay, so I think that's the question. So now what you need to observe, see, the form is the sum of these two powers is 2. 11 plus 15 is 26 by 13 is 2. So what we do, we divide by one of them. I mean, get it in terms of 1. So x minus 1 upon x plus 15 raised to the power 11 by 13. So you divided the denominator by x plus y 5 raised to the power 11 by 13. You need to multiply. So you will say x plus 15 raised to the power 15 by 13 into x plus 15 raised to the power 11 by 13. Okay, so now that's your 2. So now see, what do we do? So that's what I say, that's a standard case here. We say let x minus 1 upon x plus 15 be t differentiated. So it worked till, see, observe it. It works till you have linear expression like two linear factors whose power in the denominator, whose power add up to give 2, and both the coefficient of both the linear factors is same. They are identical factors. Okay, so see how will it work. So you use the quotient tool for differentiation. So you get 1 here, minus x minus 1, and you get 1 here. And this is dx is equal to dt. Now you solve this. So 15 plus 1 is 16. So that's it. So 16 dx by x plus 15 whole square is dt. Now you have it to be replaced by dt by 16. So that's it, bacho. Now once you replace it here, so what do we get here? So this is nothing but, I'm writing it here. So this you replace by dt. So it's 1 by 16 dt by t raised to the power 11 by 13, and that's it. So 1 by 16 t raised to power minus 11 by 13 dt, and you know how to do it. T raised to power n integral is t raised to power n plus 1 upon n plus 1. Then you can compare it with it and get the values here. Okay, so that we can easily do with you. So that's it. So okay, right. So x is 37. I'm sorry, I was actually thinking that how it's not a definite integral. So of course you will get a function of x. Sorry. Okay. So I think I didn't miss any. Yeah. So next one is this question. See, again, that's really a simple question. Okay, so it's nothing but a cos x plus b sin x. Isn't that? And we know how to convert it to either cos x plus phi or sin x plus phi or cos x minus phi or sin x minus phi. Isn't that? So since we have cos inverse out of it as composition, outer function is cos inverse, so we'll convert it. So for us that should be cos of phi. So it's cos x cos phi, and then again that has to be sin phi. Isn't that? Because their square sum is 1. Fine, bacho. So it's nothing but cos of x minus phi, and that's it. That's it. So it's x minus phi, and that's it. Now see, right, and so it's x minus cos inverse of 12 by 13. Now see, they have given, and that satisfies the condition, because cos inverse of 12 by 13, 12 by 13 is positive. Cos inverse will be in the range 0 to pi by 2, and the range of cos inverse has to be between 0 to pi. So this is positive because x is greater than pi by 2. So you may say that why have they given it? See, because if the other possibility would have been, you could have easily written cos phi minus x. Isn't that? So but when you replace it with cos inverse, then you would have got phi minus x. But then since phi is cos inverse 12 by 13, so there you will get a contradiction, because in that case it will be negative and the range of cos inverse can't be negative, so we need to adjust it. Okay, so that should be the answer here, bacho. So that's it. So moving to the next question. Next is fx is this and gx is right. Find the domain of f of gx. So what is f of gx here? It's nothing but ln of gx, because in fx you have to replace x by g of x only. So it's ln of gx, and then we know, and gx is x is power 4 minus 2x cube plus 3x square minus 2x plus 2 upon 2x square minus 2x plus 1. That's it. Okay, now see, for the ln function to be defined, we need the input to be positive. So this input has to be positive. The input of log has to be positive, and that's the only condition. And of course denominator shouldn't be 0. So let's move ahead. So input, so x is power 4 minus 2x cube plus 3x square minus 2x plus 2 upon 2x square minus 2x plus 1 should be greater than 0. Now tell me, how do we how do we solve it? Just a minute. Is there anyone? Yeah, fine. Okay, so how do we solve it? So first thing, as I said, this shouldn't be 0, but then look at this quadratic. It's discriminant. How much is it? B square minus 4ac is minus 4 negative, so that means this can't be 0. So that's not a problem. Moreover, it's an open upward quadratic. Open upward quadratic whose discriminant is negative is always positive. I believe all of you will agree with me. Okay, so open upward quadratic whose discriminant is negative is always positive. So denominator is always positive. So we are left with just this case here. And see, when numerator upon denominator has to be positive and denominator we know is always positive, so what do we need to solve? We need to solve for numerator to be positive. So positive, negative, positive, negative, positive. That's what I wrote. Now see, to solve this, to solve any polynomial inequality of degree 2 or more than 2, we need to factorize it. Never forget that. Okay, so to factorize it, I will collect these terms, x to the power 4 plus 3x square plus 2. And the rest of the terms from where 2x is common, and see, as I always say, Ishwar dayalu hai, God is great. Okay, God is so generous. Why? Because see, you got the factors. So it's a middle term split method, use it, and then you have the factors. And once we have the factor, we can solve the inequality easily. So that's it. And then again, see, luckily again d is less than 0, b square minus 4ac. Isn't that 4 minus 8, d is less than 0. This is always positive, so everything is positive, be it numerator, be it denominator, everything is positive. Okay, and moreover, are they, yeah, they are different. Okay, so everything is positive, so that means the domain of this function is for real x belongs to minus infinity to plus infinity. So every real number is a part of its domain. Find the larger area bounded by the curve. What is it? Curve. So curve is a V-shaped curve. The vertex of the V is at 1. So that's the curve here. Okay, and the circle, that's a circle with radius as 5 and center at 0, 0. So that's the circle here. Okay, so larger area of course is this area. But of course I will prefer to solve the another one. I will prefer to get this area and then from the area of the circle remove it. How will you solve it? So you need to get the point of intersection. See, now we have to be very careful. So if I plot y is equal to x minus 1 line, so which line is y is equal to x minus 1? So x is minus 1 and y is minus 1, x is 1. That's the original line. That means this you got by taking its mirror image. How do we draw the curve of mod? By taking mirror image of the negative part. So when you take the mirror image, its equation is minus times this. Okay, so remove mod, put negative sign. So these are the two curves. So this point of intersection you will get when you solve x square plus y square is equal to 25, the equation of circle. The equation of circle, when you solve it with this equation of line, bachon. Okay, so now solve it. So just replace the value y as so x square plus x minus 1 whole square is equal to 25. Achha, that won't make any difference, isn't that? Why? Because you will get it when you solve these two. Again you will be putting the same value, actually it's a square. So that means you solve any one and you get both the roots. One should be positive, one should be negative. Let's check it out. 2x square plus 1 minus 24 minus 2x 48. 8 6 48 of course. X square minus x minus 12 equal to 0. So x minus 4, x plus 3 equal to 0. So that means this is 4 and this is nothing but minus 3. Okay, so now how to get this area? So rather we have to break this region about x is equal to 1 here. Okay, so from this point minus 3 to 1, of course circle form the upper boundary and line form the lower boundary. So the area which you don't need, area we need is pi r square. So 25 pi minus, so minus 0 minus 3 to 1 under root of circle 25 minus x square d minus times minus x plus 1, isn't that line? And then plus 1 to, what was that? I think that was 4 here. Yeah, it's 1 to 4. And then again circle forms the upper boundary and the line is x minus 1 here. That's it. So solve it and you have the answer. So it might be a bit calculative, but then you should be ready for such type of calculations here. So now next is we have to solve this differential equation. So if any one of you will observe it keenly, you will find that is really a simple differential equation as far as the form of differential equation is concerned. Okay, it's a variable separable form. So I bring y term here and taking x term that side, e raised power 2x dx. Okay, now this is like anyone can do it, of course ln y plus 3, but for that, see, I will say add 6 subtract 6, so it is 7 plus e raised power 2x upon 7 plus e raised power 2x. So that's done. minus 6 dx upon 7 plus e raised power 2x. So that's done. So it's x minus, okay. Now for that one I will say that divide by e raised power minus 2x. So what will you get? Minus 6 e raised power minus 2x dx upon 1 plus 7 times e raised power minus 2x, and now e raised power minus 2x be t. So minus 2 times e raised power minus 2x dx is dt. So this is half, so 3 times dt upon 1 plus 7t bachcho. So it's again ln of 1 plus 7t by 7. So that's what I am getting. You should complete this question and see again. Answer is not important for us right now. See, the method is important, and I believe you agree with this method. Okay, so that's what I thought. Now let's move to the next one. The two vertices of a triangle are this and this. Observe the vertices bachcho. Both have same ordinate, so they lie on the line y is equal to 4. So one is minus 2 comma 4, another one is 5 comma 4, and then when it comes to point A and its ortho center is 3 comma 5, so it's above it, and triangle is 35, area is 35, centroid is this. So let's say that this is B here. Just a minute. So that's your C here. That's your C here. Okay, ortho center lie on the line which is perpendicular to the base. So I'm calling it M, the foot of perpendicular, and the ortho center lie here. Let's say this is 3 comma 5, right? Okay, we have to find the centroid. For that, see, if we get the vertices, vertex A, the coordinates of vertex A, we have centroid here bachcho. Okay, so how to get it? So that's area. Okay, so that's the base is 7, so half base into height. So let's get height from here. So h is 10. 10. Okay, got it. See, that's a vertical line because base is horizontal, so altitude has to be a vertical line, so abscissa is same. So whatever the abscissa of ortho center, so on with any vertex, any like point lying on the vertical line has same abscissa. So 3 comma, and then it is 10 units above because height is 10 units, so it's 10 3 comma 14, and that's it. So centroid is nothing but x1 plus x2, so 3 plus 3 3, and then 14 4 18, and then 22 by 3 if I'm not wrong. So you have C and D. C plus 2D is equal to, so there might be some problem because 2D I got here 3. Check it out, but okay, that's how we can approach. See, the basic thing is base is a horizontal line, hence altitude on which orthocenter lie must be a vertical line. So using it we got abscissa of this vertex, and then we got height using area, and then we got its ordinate also, right? So now moving to the next one, two biased die are tossed. Die 1 has 1 on 2 faces, 3 and 4 on other faces. While die 2 has 2 on 2 faces, 4 on 2 faces, 2 and 3 on other faces. Okay, so dies 2, the combination is 2 and 3 on other faces. Oh, chaliye, let's 2 on 2 faces, 4 on 2 faces. It can't be 2 on 3. So if I take it as 1 and 3, let's see. I mean, see, I'm just trying to like reframe the question because see, the data is missing here also. 1 on 2 faces, so 1 comma 1. 3 and 4 on other faces, they didn't specify how many times. So if I assume it to be 3 3 4 4, okay, just to discuss how to approach this question. Okay, so whatever the like combination of numbers on the faces be, approach will be same. So what is the probability that when throwing these dice we get 4 or 5, sum as 4 or 5. Okay, so sum as 4. Now how can you get 4 here? You can't get 2 and 2 because there's no 2 here. Okay, so you get 1 from here, 3 from here. So what's the probability of getting 1 from here? It's 2 by 6, isn't that? Because on 2 faces you have 1. What's the probability of getting 3 from here? It's 1 by 6, or 1 and 3. Or you get 3 from here and 1 from here. So it's the same thing. Getting 3 from here is 1 by 6, and 1 from here 1 by 6, and 3 from here is 2 by 6 is the same thing. Okay, so probability of getting 4 is 4 by 36. That's it. Now sum as 5. Now sum as 5, the possibility is 2 3 1 4. Okay, there are 2 possibilities. So 2 3 combination is 2 by 6 into 2 by 6. Okay, plus 1-4 combination is 1/6 and 2/6, or 1/2/6 and 2/6. So according to the given data and some in like own addition, my own addition here, 3 and 4 are twice, both are on two faces, then what we need is either or situation where we know we add up the probability, because there is nothing common between 4 and 4. Either you will get sum as 4 or you get sum as 5. It's not possible you get both as the sum. Okay, so you just add them up. So 2, 2, 4, and then 4, 8, and then 12, and then it's 14/36. So according to this data which I have in front of me, that should be the answer. Answer doesn't matter, what matters is the approach. So I believe you people will be will agree with the approach here. So that's it. So now moving to the next question. System of linear equation has infinite solutions, and see, it's a homogeneous equation. So homogeneous equation, to have infinite solution, the determinant is 0, determinant of coefficient matrix. So it's for x 1 plus lambda, lambda for first one, lambda plus 2, lambda minus 1, then it's lambda, lambda minus 1, lambda plus 1, then it's lambda minus 1, lambda plus 1, and then lambda plus 2, and that's 0. Just solve it, you get lambda, and hence the value for lambda square plus lambda. So whatever we get, that you can easily evaluate here. So now moving to the next one. Oh, that's it. So those were the questions. Those are, I think, those are 14-15 questions here from your day 2, today's shift 1 paper. So now you are through this paper. What will you say? I believe you will say it was an easy paper, barring few questions here and there. So if I go back here, just a minute, if I go back quickly, and then where is it gone? Yeah. So see, this was easy question in front of us. I will say that was again a easy question. Okay, data might vary, but it was an easy question. That was a bit tricky. If you use whatever I just use here, it's a simple question. Otherwise, it might be a very lengthy question. But again, doable one. That's really a doable question. Okay, integration part might be tricky, a bit tricky because of this integral, but I know you all can handle it. So again, I will rate it as a simple question. Again, a simple direct question of area, no problem at all. About this I will say again a bit tricky one because of the factorization of this numerator part. Otherwise, no big deal. So I will again take it as a bit better question. And then this one, really a simple question. Just keep in mind the range and you get the answer. Really a very simple question. This one, yeah, that's a direct form. I normally we discuss it in the class. So if you remember, it's a really simple question. If not, then definitely a tricky one. So it depends whether you remember it or not. That's a direct simple application of multinomial, general term of multinomial. I believe most of you must be knowing it. Again, equivalence relation, in any case you have to count it. Your count may be +1 -1, and then you end up getting -1 mark. So in such type of question you have to be extremely careful. Otherwise, a simple question. First, very simple question of AP, really a simple question, 10 class question. This I will definitely say a better question in this session, okay, in this shift. So integration question was a bit better one. This one also a good one on the like application of derivative and the curve of cubic polynomial. That are really a simple direct question of PNC, a simple one, and that was again a really a simple one. So according to me, it was a simple, little. Okay, if I say okay, at most it's a moderate paper, and not even that much lengthy. That's what my analysis is for these 14-15 questions. Maybe the rest of the 10 questions or 11 questions might be lengthier or tricky. So that we will analyze maybe later. But that's what I will say for today's first day of second day first shift, bachcho.